Navigating and data table files. This is where we left it when we were in our last presentation. We were discussing RS links, and I have closed the RS-Who1, which was the DF1 driver. Now I'm looking at RS-Who2, which is the Ethernet IP, and I'm going to use Ethernet IP. You can use either one. For what we're doing in classes, it's not going to make any difference. The speed just isn't needed for those small files that we're uploading and downloading. So I'm going to minimize RSLinks Classic Lite. Remember, Lite is what is bundled with all of the software packages at no extra cost. I mean, it's free in a sense because you can download it separate without buying it. But it is the Lite version, but it is more than sufficient for everything that we're doing. And I'm going to bring back up the project that we created called RS-232DF1. That wasn't part of the lab projects. As a matter of fact, when I had you create a lab project, when I had you name the project, you actually name the processor. The name of the processor and the name of the project are not the same thing. They are initially because you created a new project, you named it class, so to speak. The controller that you selected, you named it CLASS. It doesn't matter what you named it. And you download it, the processor is named class, and your project might be named class, but they don't have to be the same thing from here on out. I'm going to save my project as, I'm offline, I'm going to save as, and I'm going to just call it ML1400 Lab Navigate Edit Database, and I'll just put a 01 after it, and I'm going to save it. And I name my stuff so I can find it. You know, I may tell you to save it as one name in the manual, and then I turn around and give it a different name. But I do always explain to you, you can pick any naming scheme that you want, as long as you can find your projects later on if you want to go back to them. I had you open up the data files, beginning with the output. So we're starting right with 0. See, here we have 0, 1, 2. Those are program files. 0, 1, 2, 3, 4, 5, 6, 7, 8. These are the default data files. When you create a project, this is what you get. And you get one element of each. And I had you open up the output to see what you had. You only have, with this processor, you have 12 outputs. So here, all the rest of it's hanging out in the breeze. This particular slot, 0, will support 6 words. But we're only using the first 12 bits. 0 through 11. Now I could go back here and double click on I1 input, or I can go down here and just click up and go from 0 to 1. Here you don't see the 1. Back here you didn't see the 0. You saw O slot 0. And here you see I slot 0. Well, you only have 20 inputs. Well, there's 16 right here, and then 4 right here. 0, 1, 2, 3. All the rest of this is hanging out in the breeze. Now S2, that's the status file, whereas the output and the input files can be configured a little bit. This one is fixed. That's why everything looks grayed out, and it's shown as structured. So if I change the radix to binary, now you see all of the words shown at the bit level. We're going to leave it structured because that's the easiest way to look at it. Processor, bits and words, scan times, math, functions, channel 0, which is RS-232. Debug, error protection, memory module. We're not using memory modules. And forces. We'll look at a little bit when we're doing labs, not right now. B3, that's the first data file that you're going to use a lot. And notice that there is one 16-bit word. That's an integer. B3:0 is an integer. So I can show it in decimal. See, this would be B30 right here. B3:1:2. but these don't exist. Now, if I wanted them to exist, I could go to properties for this file. I can either say I want 2 elements, or I can type in the last element. I'll put in B3:1 and apply. See, now it says 2. Or I could put in 3 here and then watch this value over here. B3:2. See, now I go back here. Now I've got 3 of them. And if I go back to binary, because that's the form that you're using, binary, now you see you have 3 integers, B3:0, B3:1, and B3:2. By the way, I can lock this on top if I want. When you do that, it's going to resize itself regardless of what you've done. Okay? And when I lock it on top, then clicking on something else doesn't bring that something else to the forefront and block this. It keeps it locked on top. I'm going to uncheck that. Resize it again. Now see, if I click on this, it disappeared. It's still there, but it's back behind everything. I'll bring it back out by double clicking on it. And we'll jump up to timers, T4:0. You have 1 timer data type, but a timer data type is made up of 3 elements, 3 integers. You have the preset, that's an integer. You have the accumulate, that's an integer. And then these values right here are all combined into one other integer. Your 3 control bits, enable, timer, timing, and done bit, and then the time base itself. So just for grins, we'll make this 10 elements. So we have 10 timers now, 0 through 9. See, 0 through 9, including the presets, accumulates, and everything else. So let's bump this up to counters. This is the counter data type. And these are your control bits. And then there's your preset and accumulate. So that's 3 integers. These are buried in an integer, and then each of these are separate integers. And just for grins, we'll go in and make 10 of those puppies. Remember, we clicked on properties, we typed in 10, or we could have put in C5:9. Now we'll go up to our control data file, and this is a completely different style. This is, again, is 3 integers, but if you look at the designation for these control bits, we're not going to explain them right now, that would muddy the water. But you have the control bits, you have the length and position, not preset and accumulate, length that you're going to control and what position the control is on right now. That's enough said about that. And then, of course, integer. Now, the only difference between a B file and an N file is the B and the N. Other than that, they look the same. And you can use these individually as bits, or you can use them as words. In other words, N70, used as a word, would be assigned integer value. I can go back and do the same thing with B3 at the word level. So I can use B3 and N7 both at the word and bit level. So let's go to the last one, that's floating point. Let's go back to N7 and we'll make that 10 as well. Okay, see, now we have 10 integers. It's displayed as binary, but typically you use them as decimal. But you can use them either way. So that's N7 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have floating point. And we'll go in there and we'll make that 5. I'm not doing this for any particular reason, 10 or 5. I'm just expanding them to show you how to do it. Notice that you cannot change the radix on F8, but you can on F7. R6 you cannot change the radix. Or on counters, or on timers, because these are complex data types. But you can on B3, your S2, you can show your I/O as integer. Well, more than, I say integer, decimal. So you can change some of the files. We'll go to the bottom one. So outputs, inputs, you can change the radix. S2, you can change the radix. B files, you can. Timers, counters, and control, you cannot. Integers, you can. And floating point, you cannot. That's a quick rundown on the data files. What I had you do in there was to open up the output, lock it on top, and then I had you drag it over. We don't need but this one right here. And then inputs, do the same thing, lock it on top. And then you can, well, we've got it as decimal right now because that's how we left it. We'll go back to binary. We only care about the first couple. Then I had you set the first bit of the first word in both of them to 1. So click here. Now, if I just hit 1 and then leave, watch that right there. I'm going to go click someplace else. It didn't change it. You have to put in 1, enter. 1, enter. I also had you open up B3. You see, this was last open, but notice it opens up behind these because we locked those on top. So now let's lock this one on top. We'll collapse it down as best we can. We'll put it down here, and we'll set this bit to 1. Next in the manual, but I've already done this, I had you save your project. So I'll just go up and click save because that's what I told you to do. Now I'm going to have you download your project, and there's several ways you can do it. You could go over here and say download, but this is pinning the tail on the donkey. As a matter of fact, if you were to do that right now, that would not work. And this is a good opportunity to show you that. Just make sure that my cable's correct. So I'm going to hit download from here. Then I'll tell you why. You see the cursor is twitching. The busy signal is twitching. It's straining, trying to download. But something's missing. Something is amiss. No response from processor at selected path node. Selected path node. That's the key word right there. I did not select a path node on purpose. However, I did by using this toolbox right here. See, it shows driver ABDF1-1. That's because we were using, or I was using, the RS-232-DF1 driver the last time I did this. So as far as it knows, that's the driver. So when it says failed at selected path, when I hit download from right here, I am basically selecting that as the driver path node. Now I'm going to go do it the right way. You should always do it the way I'm going to show you right now. Doing it over here, if you've only got one controller out there and there's no way you could accidentally download to the wrong one, I suppose. So comms, system comms, you pick it. Okay, now see DF1 is showing nothing because it's not there. Now we got our Ethernet IP showing up. Now I click on that. I can click on it here or here. It really doesn't make any difference. And I can download. I don't usually put in comments. Remember, I explained this. You're downloading a program set up as a 1400B to an actual 1400B. It says the project settings do not match. Current driver, ABDF1, driver selected, Ethernet 1. Would you like to replace the project settings with the new system settings? Well, you can do two things right now. I'm going to say no, okay? Because what I have in the controller is what I want. When I created the new project, maybe the settings aren't right. So I'm going to say no. And I'm going to go back up here to channel configuration. Go to channel 0, that's 38.4. Channel 1, that's 226, so that should be okay. Now we'll go back to system comms and do that again. I just went and double checked. Now let's look again at our channel configuration. Channel 0, 38.4, channel 1, which is the channel that we're on. I don't have the RS-232 cable connected. That's why it didn't work when this said RS-232 DF1, because that cable wasn't connected. The driver could not have worked. So we're in the remote program mode, and I believe I told you to leave it in the remote program mode. In the manual, I had you download, but stay in the remote program mode. And then I ask you, are the values of those 3 bits in the same state as they were in the offline data files? Yes, they were. What conclusions can you draw from this observation? That the offline data table values download to the online data table when you download the program files. Then I ask you to record the state of these 3 memory locations just to make sure you're in the right spot, and of course all 3 of them are 1 or on. Then I had you drop down your online menu and pick run and then answer yes, and do so keeping an eye on these 3 values of 1. The one you want to watch in particular is this one right here, the input word. So we click yes. Notice it instantly goes to off or 0. The other 2 stay on. And then I had you record those values. So the output bit was still on and the B3 bit was still on, but the input bit was now off or 0. Are any of your output indicators illuminated? Yes, mine is. Which one? Output 0. Why? Because we downloaded a 1 to that data file, the O or 0 data file. We downloaded a value of 1 and we put it in the run mode. The controller did its job. It scanned the inputs, set input word 0 bit 0 to 0 because that input is off, and then it turned on, because bit 0 of the output word was 1 or on, it transferred that out to the actual output. Do the values match those before run mode was initiated? No, they do not. Which do not match? Well, input word 0 bit 0. What is your opinion on why they do or do not match when the processor was switched to the run mode? Well, the first thing that happens in a normal scan is the inputs are updated, and because that input is off, it updated the value of bit 0, word 0, the input file, to 0. And then it does the logic, but there's no logic to alter the states that you downloaded for B300 and output 00. They stay 1 because those can only be controlled from your keyboard or downloaded or in logic. The inputs are updated regardless because they're updated from the field state. But the rest of it, nothing's going to happen to any of the other files other than the input unless there's some logic. In this case, we downloaded a 1 into bit 0, the output file, so it turned that on. If we were to go turn on bit 1 right now, we could go up here and click on this, change it to 1, and now I have 2 lights on mine. So I'll hit 0 and put it back the way you had yours. Next, I had you save. Well, I had you go offline without saving any online changes. So I'm going to go up to my online menu and I'm going to pick off, go offline, but I'm going to say no. Okay? Before I do that though, take one last look at these values. Output 00 is 1, B300 is 1, and input 00 is 0. So save, changes, no. We went offline, now let's open those back up. We'll start with our output. We'll lock that on top. I'm not going to collapse them just to save some time. Inputs, lock them on top. Now, right away you should notice something. Okay, and then the manual, Compare the state of these 3 bits to their offline state before you downloaded them to the controller in an earlier step. Are they the same? Compare the state of these bits, these 3 bits, to their online state before you switch to the offline view. Are they the same? No, they're not. Where is the state of these bits stored in the online view, controller RAM? So they are identical to what they were before you downloaded, but they're not after you downloaded, because the input scan changed the input word 0, bit 0 immediately to 0. Where is the state of these bits stored in the online view, in the controller's RAM? Where is the state of these bits stored in the offline view, in the laptop or your computer's RAM? How many possible locations can the state of these bits be stored at any given instant? Well, in our case, it's 2, on the laptop RAM and in the controller's RAM, but it could be more. If you saved it to your hard drive, it's saved there. If you saved it to an optical disk, that's another one. If you saved it to a server, that's yet another one. If you saved it to a jump drive, that's yet another one yet. The important thing here is for you to realize that if you download these 3 states to a controller, go in the run mode, and they get altered, they are now different in the controller than they are here in the offline data table that's in the RAM of your laptop or desktop. If you save, or if you go, not save, but we did not save. If you go offline, then you're going right back to the offline data table just the way it was when you left. If you had saved the online data table values, then input 00 right now would be off.